Another stationary application. Your garage. I've left some space here for what, coming out of heaven, a fuel cell. 5 kilowatts, about what you want. And we have today in Southern California an Oregon company that is selling proton exchange membrane fuel cells for the garage, Clear Edge, and many others who are starting to get into this market. It provides electricity and waste heat. Now, this is thinking a little bit outside of the box, and I say some, I'm thinking of Honda and GM. Honda working with Plug Power, GM working with Quantum are considering that this could also be a source of son of a gun. This is a competitor to Clear Edge. Where did they come from? Plug Power. And I have to admit, it's a little bit larger than what I have here. It's about that size, but still not too bad. So what is Plug Power doing with Honda? They are working with this concept of being able to refuel like we do with natural gas today in the garage with hydrogen. This is a segue into this connection or this nexus between stationary fuel cell applications and transportation applications. Here we have the stationary. Let me kind of move that up the chart, bring back the mobile application that you see here, which requires hydrogen. And you can see what I've done here. I brought the hydrogen from this product of reformation in order to provide the fuel for the vehicle. An example of this would work is to bring a fuel cell, again out of heaven, into the gas station or hydrogen station, operated with natural gas, and it would supply a local customer like that condominium across the street with electricity, with a thermal product, and then on demand provide hydrogen to the station. This is today the most energy efficient and environmentally responsible means of generating hydrogen 24/7 using a high temperature fuel cell, because when you extract out hydrogen, there's a synergism that actually makes the fuel cell more efficient. It's kind of shown here with this slide. Here's the fuel cell being provided with natural gas, which is mostly methane. That fuel cell, when it's operating at the Sierra Nevada brewery or anywhere else, will provide this about 47 megajoules of electricity, and then the resultant high quality heat that can be used. If I increase this, I can demonstrate the trigeneration of hydrogen. So let me kind of change things here and expand things out here to a label that I want you to keep your mind on, trigeneration of hydrogen. Best demonstrated here by just increasing this by 43 megajoules. Put in more natural gas here. I still get out the same amount of quality heat and electricity, but now I get hydrogen at basically 100% efficiency because of this synergism that occurs within the stack as we put more hydrogen at the anode. What that means is that for this particular technology, using fuel cells, we're able to come down to a much lower footprint on the provision of hydrogen with respect to the CO2 signature. But I can take it a step further. And now I get into Mike Dittinger's presentation this morning, remember, on water? What I'm going to do here is to replace natural gas with what we call renewable gases. That can be a digester gas or a landfill gas. And this energy station, which is a label given to this concept in the Schwarzenegger Blue Ribbon report on the hydrogen highway, May 2005, is now not just an energy station, but it's a renewable energy station with renewable electricity, renewable thermal product, and renewable hydrogen. What that does here is to reduce the signature operating on the biogas to zero. How would it look in Mike Dittinger's wastewater treatment plant? Here's the wastewater treatment plant. We process all of our sewage. We create this anaerobic digester gas. That, along with natural gas, is used to produce heat for the digester to digest our human waste. Coming out of heaven, forgive me, that's the way it's coming, is the high temperature fuel cell that now not only produces the heat for the digester, but produces AC power at this overall exceeding 80%. But now, well, before I get to now, there's about 8 megawatts of this deployed around California today. So as Bill Reiner said, it's not science fiction, and it's going up rapidly as wastewater treatment sanitation agencies recognize the value of this strategy from every side of their operations. But they can now also consider a future where this can tri-generate hydrogen on demand. Now, this is a little bit of science fiction, but it's transitioning into reality in that there's a project, Orange County Sanitation District, which is at the Euclid exit of the I-405, and in July there'll be a commissioning of this technology for you to actually be able to witness. There'll be a refueling station where you can refuel on hydrogen. And the team that's put together for that is Air Products, Fuel Cell Energy, and the National Fuel Cell Research Center, with support from the Department of Energy, Air Resources Board, and Air Quality Management District. A few more slides to go, but one more transition or two. Still begs the question of how are we going to get that infrastructure out there? So let me just go through a little analysis here for you. This is Irvine and Newport Beach, two so-called hydrogen communities established by the California Fuel Cell Partnership. There are how many gasoline stations? 59 in this area. And the question becomes, how many hydrogen stations would you need to serve the public? And the answer, of course, is 59. But as we start to look at some of the demographics that are important, we first look at the existing hydrogen stations, and there are 2 existing, and then this Orange County Sanitation District station upcoming. What about the residential land use of this area, GIS data? What about the OEM market information, companies such as Toyota, Honda, General Motors that have been polling the public to find out where is their interest within these communities for hydrogen? And you take that into account and you find out that the number of hydrogen stations that you need to satisfy the public to the degree they're satisfied today with the 59 stations is 14. About 1/4 of the number of gasoline stations required. And one way to satisfy them is in travel times from their home to the stations, and these all satisfy the same travel time that the gasoline stations provide today.